Across the southeastern United States, 500,000 oval depressions scar the landscape. They're called the Carolina Bays. Most stretch between 500 feet and 3 miles long. They all point northwest to southeast. And mainstream geology has no adequate explanation for how they formed. 12,800 years ago, something catastrophic happened. Ice cores from Greenland show a sudden spike in platinum and iridium. Elements rare on Earth's surface, but common in asteroids and comets. Within decades, temperatures plummeted. Megafauna across North America went extinct. The Clovis culture vanished, and 500,000 elliptical craters appeared across the Atlantic coastal plain, stretching from New Jersey to northern Florida. The evidence suggests a comet airburst. Not a single impact, but a fragmented object exploding in the atmosphere, sending thousands of projectiles into the ground at supersonic speeds. The energy released would have been equivalent to millions of megatons of TNT. The Carolina Bays might be the geological fingerprint of the event that ended the Ice Age. Before we go further, comment below. Where in the world are you watching this from? I want to know how global this audience is. United States, Canada, Europe, Australia. Drop your location in the comments right now. For decades, geologists attributed the Carolina Bays to wind and water action. Natural processes shaping shallow depressions over thousands of years. The problem? Wind doesn't create 500,000 identically oriented ellipses. Waves don't excavate inland basins with raised rims. And normal geological processes don't deposit the shock-fractured quartz grains found in Carolina Bay sediments. The bays share specific characteristics that point to a common origin. Their long axes align within a few degrees of each other. They're surrounded by sand rims on their southeast edges. Their depth-to-diameter ratios match impact craters elsewhere on Earth. And geophysical surveys reveal shocked minerals and magnetic anomalies consistent with high-velocity impacts. In 2007, researchers presented evidence of a cosmic impact at the Younger Dryas boundary, the geological layer marking 12,800 years ago. They found nanodiamonds, carbon spherules, and magnetic microspherules in sediment cores across North America, Europe, and Asia. These materials form only under extreme temperatures and pressures, conditions created by cosmic impacts or airbursts. The distribution pattern suggests multiple fragments from a disintegrating comet striking across thousands of miles. The timing aligns perfectly. The Younger Dryas climate event began abruptly, 12,800 years ago. Temperatures in the northern hemisphere dropped by 15 degrees Celsius within decades. This cold snap lasted 1,200 years before temperatures rapidly rebounded. Ice cores show the transition happened so fast that a single human lifetime would have witnessed the change from ice age to interglacial warmth. If this evidence is challenging what you learned in school, hit the like button right now. It tells the algorithm to share this with more people questioning mainstream geological narratives. Pause and like this video. The Carolina Bays aren't the only evidence. In Michigan, similar oval depressions called Saginaw Bays display the same northwest-southeast orientation. In Nebraska, the rainwater basins show identical patterns. Across the Great Lakes region, elliptical lake beds align with the Carolina structures. The distribution forms a vast ellipse, stretching 1,500 miles from the Great Lakes to the Gulf Coast. Exactly what you'd expect from an airburst trajectory. Computer simulations of comet airbursts produce crater fields matching the Carolina Bay distribution. When a comet fragments in the atmosphere, the pieces continue on similar trajectories, creating aligned impact patterns. The angle of entry determines the ellipse orientation. The fragmentation altitude controls the crater density. The models predict everything we observe: 500,000 craters, consistent orientation, and a specific geographic distribution. Mainstream geology remains skeptical. The dominant explanation still involves wind and wave action during the Pleistocene epoch. Some researchers propose Carolina bays formed through subsurface dissolution of limestone, creating sinkholes that later filled with water. Others suggest artesian springs undermined the surface, collapsing sediments into depressions. But these theories have problems. Limestone dissolution doesn't explain the uniform orientation. Artesian springs don't create raised rims. Wind deflation over thousands of years doesn't produce the shock-fractured quartz found in bay sediments. And none of these processes explain why the bays suddenly stop at specific geographic boundaries, exactly where comet fragment trajectories would have ended based on atmospheric entry angles. The evidence keeps mounting. Researchers analyzing Carolina Bay sediments have found microscopic diamonds, nanodiamonds formed only under extreme shock pressures. They've documented magnetic spherules created when cosmic material vaporizes and recondenses. They've identified platinum and iridium spikes matching other impact sites worldwide. And they've found carbon spherules with features indicating combustion at temperatures exceeding 2,200 degrees Celsius. Core samples from bay sediments reveal layers of charcoal and ash dating to 12,800 years ago. Pollen analysis shows sudden vegetation changes consistent with massive wildfires. The timing matches precisely with the Younger Dryas boundary markers found across 2 continents. Pause right now and comment your answer. Do you think the Carolina bays are impact craters from a comet airburst? Comment 1 if yes, or 2 if you think they formed through natural geological processes. I read every comment and respond to the most compelling arguments. In 2022, analysis of Greenland ice cores revealed a platinum anomaly at the Younger Dryas boundary. Platinum concentrations 100 times higher than background levels. Platinum is rare in Earth's crust, but abundant in asteroids and comets. The spike appears in ice cores across Greenland, indicating a global atmospheric event, not a local anomaly. The impact hypothesis explains something else mainstream geology struggles with: the Younger Dryas climate catastrophe itself. A comet airburst over the Laurentide ice sheet would have instantly vaporized trillions of tons of ice. The resulting freshwater pulse into the North Atlantic would have disrupted ocean circulation patterns, shutting down the Gulf Stream. Without warm water flowing north, temperatures plummeted. The megafauna extinctions coincide exactly with the impact date. Mammoths, mastodons, saber-toothed cats, giant ground sloths, and dozens of other species disappeared within centuries. Of 12,800 years ago, North America lost 35 genera of large mammals, 72% of its megafauna. The extinction pattern shows no gradual decline, no adaptation period. Populations crashed simultaneously across the continent. The Clovis culture vanished at the same moment. Clovis points, distinctive stone tools found across North America, appear in archaeological sites dated before 12,800 years ago. After that boundary, they disappear. The archaeological record shows a cultural discontinuity matching the climate catastrophe. Whatever happened didn't just change the environment, it disrupted human societies across an entire hemisphere. Could a comet airburst cause this level of devastation? The 1908 Tunguska event in Siberia provides a modern comparison. An asteroid or comet fragment exploded over remote forest, flattening 770 square miles of trees. The blast released energy equivalent to 15 megatons of TNT, 1,000 times more powerful than the Hiroshima bomb. Yet Tunguska was a small fragment. The Younger Dryas impactor was orders of magnitude larger. Evidence suggests a comet nucleus at least several kilometers wide, fragmenting into thousands of pieces during atmospheric entry. Some fragments exploded in airbursts like Tunguska. Others struck the Laurentide ice sheet directly, vaporizing ice and creating temporary craters that melted away. The Carolina bays represent the ground impacts, fragments striking softer coastal sediments at angles shallow enough to create elliptical craters rather than circular ones. The energy released would have ignited continental-scale wildfires. Soot layers in sediment cores from 12,800 years ago contain charcoal from burned biomass across millions of square miles. The smoke and ash would have darkened skies for months, suppressing plant growth and collapsing food chains. Combined with the sudden temperature drop, ecosystems couldn't recover fast enough to support large mammals. Recent research strengthens the impact hypothesis. In 2019, researchers identified a 31-kilometer-wide impact crater beneath Greenland's Hiawatha Glacier. Dating techniques suggest it formed sometime in the last 100,000 years, possibly coinciding with the Younger Dryas event. If confirmed, this would be direct evidence of a major impact at exactly the right time. The Carolina bays represent just one aspect of a global catastrophe. Similar crater fields exist in Europe. Sediment cores from the North Atlantic show disrupted ocean circulation patterns beginning 12,800 years ago. Archaeological sites across Europe document sudden cultural changes matching the American evidence. The event wasn't regional, it was hemispheric. Here's what mainstream geology struggles to explain. How do you get 500,000 identically oriented ellipses through wind and water action? How do you deposit shocked quartz, nanodiamonds, and platinum anomalies through normal processes? How do you create magnetic spherules without extreme heat? And how do you make all of this happen simultaneously 12,800 years ago, the exact moment when climate records show catastrophic disruption? The alternative explanation, Comet impact, accounts for all the evidence. The crater orientation matches expected trajectories from a northwest-southeast atmospheric entry. The shocked minerals indicate extreme pressure and temperature events. The platinum and iridium spikes confirm extraterrestrial material. The timing coincides with documented climate catastrophe and mass extinctions. And computer models of comet airbursts predict exactly what we observe in the landscape. What if advanced human societies existed before the Younger Dryas impact? Coastal civilizations would have been most vulnerable. Sea levels rose 400 feet as ice sheets melted over the following millennia. Any settlements along Ice Age coastlines now lie under 300 feet of water on continental shelves. We're only beginning to explore these submerged landscapes with advanced sonar technology. The Carolina bays aren't isolated anomalies. They're part of a pattern. Göbekli Tepe in Turkey dates to 11,600 years ago. Built just after the Younger Dryas climate stabilized its sophisticated stone architecture, suggests building traditions that must have developed earlier. Where are the earlier examples? Perhaps they're buried under post-impact sediments or drowned beneath risen seas. Across the northern hemisphere, ancient flood myths describe global catastrophes involving fire from the sky, rising waters, and the destruction of previous worlds. The Ojibwa people of the Great Lakes region have oral traditions describing a great star falling from the sky, bringing fire and flood. Norse mythology describes Ragnarok, a world-ending conflagration followed by submersion. These stories might preserve cultural memories of the Younger Dryas impact. The evidence raises profound questions. What capabilities did pre-Younger Dryas humans possess? How many settlements lie buried under impact debris or drowned on continental shelves? What knowledge was lost when those societies collapsed? And how did survivors rebuild in the aftermath of global catastrophe? Research continues. New crater discoveries, refined dating techniques, and advanced geophysical surveys keep adding pieces to the puzzle. The Carolina Bays stand as visible reminders that Earth's recent past involved catastrophic events we're only now beginning to understand. The geological evidence is undeniable. The debate now centers on interpretation, not whether something catastrophic happened 12,800 years ago, but exactly what caused it and what the full consequences were for human civilization. As exploration technology improves and researchers examine more sites, the picture becomes clearer. If you found this evidence compelling, consider subscribing. This channel examines archaeological and geological mysteries through scientific evidence, not speculation. We question mainstream narratives when data demands it, and we acknowledge